Giant furnaces roar as massive steel billets are heated to over 1,200 degrees Celsius, then forged into grinding ball blanks. Hydraulic presses apply tons of force, shaping each piece with precision. The rough spheres are rolled, quenched, and tempered for hardness control. Metallurgists test core samples to ensure uniformity and wear resistance. Advanced labs partnered with top Chinese universities support continuous R&D. Global mining clients, including those from Chile, Australia, and Poland, visit regularly, drawn by the scale and consistency. 500,000 tons a year isn't just a number, it's a commitment to industrial demand. The process is loud, intense, and surprisingly methodical. That forging sound? It means power. Stripping armored cables isn't a gentle task. It demands power, control, and the right machine for the job. This is the Mississippi 120 electric cable stripping machine, designed to process cables with outer diameters ranging from 10 to 120 millimeters. It handles all types of insulation: PVC, rubber, steel, lead, even heavily armored layers. The core of the machine features two cutting shafts, one fixed, one adjustable. The upper shaft height is fine-tuned using a top hand wheel, while side knobs set the cable guide width for stable feeding. Both shafts are equipped with cutting blades, allowing continuous operation even under thick outer jackets. With a 3 kilowatts motor running at 380 volts, it can process over 3,000 kilograms of cable per day. Every knob and dial has a purpose. Setup may take minutes, but once it's dialed in, this unit becomes a serious cable recycling powerhouse. Round steel pipes are squeezed into thick-wall square profiles with powerful rollers. The transformation is fast, noisy, and oddly satisfying to watch. Industrial precision in action. Steel doesn't bend itself, but this machine makes it look effortless. What you're watching is a fully automated process of cone forming using a 3-roll bending system, and it's packed with technical precision. A massive steel plate is being shaped into a cone using a 3-roll bending machine, and the process is as technical as it is mesmerizing. The plate is pre-cut with tapered edges, designed specifically for cone geometry. Once fed into the machine, it aligns automatically between 2 lower rollers and 1 upper roller. No human hands adjust anything. The system is programmed to control every stage. Every motion is calculated, every shift intentional. Watch the machine roll forward slowly, then reverse. It doesn't just bend in one go. Each pass applies a slightly different pressure profile, gradually increasing curvature. What's fascinating is how it pivots the plate upward between passes. That upward swing isn't random. It redistributes force where it's needed most, helping to refine the taper and reduce residual stress. It's like watching muscle memory in metal. The wider end lifts with more arc, while the narrow end tightens inward. You can see the cone forming as the angle deepens with each cycle. All of this happens with no stops, no pauses for measurements. It's pre-calculated, automated forming. The key is how the rollers apply uneven pressure across the width. By angling the material and rolling it in short, sequenced motions, the machine sculpts a conical form without warping. It repeats this rotate-lift-roll pattern several times until the edges nearly meet. At the end, the cone holds its shape with just a small seam visible. Final steps like edge trimming or welding prep are done afterward, but the forming itself is already spot on. No sparks flying, just the silent accuracy of mechanical confidence. It's incredible how precision engineering and automation work together here. No operators hovering, no trial and error, just programmed efficiency shaping industrial-grade steel into a perfect cone. Some machines don't just cut metal, they confront it. The Lensinger KSS800 circular saw is one of those rare beasts, engineered not for show, but for relentless industrial work. Steel billets, often bent or uneven, are loaded onto the feed system. A hydraulic mechanism positions each piece with precision. Then comes the grip, a three-point clamping system that locks each billet in place. Even misshaped metal doesn't stand a chance. You can almost feel the force through the screen. Cutting begins with either LINCUT or brazed saw blades, spinning at intense speeds. Unlike standard saws, this hybrid design blends horizontal and vertical force, directing chips downward for better evacuation and cooling. The sound is harsh, pure metal being conquered. Sensors continuously monitor blade condition, temperature, and cut alignment. Any deviation triggers real-time corrections, preserving accuracy even during non-stop 3-shift operations. Finished billets are conveyed out with clean, uniform ends, ready for the next phase of production. Watching it all unfold is unexpectedly gripping. There's something satisfying about that fusion of pressure, precision, and purpose. The KSS800 isn't just a tool, it's the force behind transformation. It's hard to believe how much work goes into something as simple as a cooking pot. But step inside this production line, and you'll never look at your kitchen the same way again. Everything begins with coiled sheet metal, flat, cold, and full of potential. Large unrollers feed the steel into cutting machines, where it's trimmed into rectangles based on the product's dimensions. These sheets are then clipped into perfect circles. The precision at this stage sets the tone for the entire process. From there, hydraulic presses stamp the discs into deep-drawn forms, shaping the basic pot body. Next, the edges are trimmed, and the bottom gets its final contour. Even this early on, the transformation is striking. What once looked like raw steel already hints at its future purpose. The pieces then head to a 4-stage washing system, where oils and impurities are removed to ensure flawless surface preparation. Cleaned and dried, the pots are transferred to the enamel section. Here, a powdered glass mixture, ground and mixed with water, is turned into a slurry. Each pot is dipped into the tank, evenly coated inside and out, then placed onto racks for firing. Timing is critical here. Too short or too long, and the enamel won't bond correctly. The first firing begins at 770 degrees Celsius. When the pots emerge, the enamel is solidified, smooth, and permanently bonded to the metal. But they're far from finished. Once cooled, the pots move on to the coloring stage. Just like before, they're dipped, this time in colored enamel. Another round in the 770 degrees Celsius kiln follows. That intense heat locks the pigment into the surface, giving it a bright, durable finish. Each pass through the furnace makes the product stronger and more refined. Now comes the most delicate part, decoration. Skilled hands apply patterns and speckled textures, taking care not to trap moisture or distort the design. These are sealed and cleaned again before a third trip into the furnace. Yes, 3 firings, because flawless cookware isn't rushed. There's almost a ritualistic rhythm to how each detail is handled. Even after all this, the process continues. A metal ring, known as a belt, is cut and shaped to fit each pot's rim. This ensures strength and a finished look. The ring is pressed on using a precision machine. The fit must be exact. Any gaps, and quality control rejects the piece. Finally, the pots are inspected, stacked, and packaged for shipping. What looks like a humble kitchen item is actually the result of dozens of steps, hundreds of details, and serious craftsmanship. It's honestly impressive how much care goes into each piece. Watching this unfold feels like watching art being forged in fire, repeatedly. Who knew Enamel Cookware had such a story? There's no mold, no preformed shell, just steel, rotation, and human force. This is the raw beginning of how a 120-liter steamer is born in the workshop. It starts with a raw disc of stainless steel, spinning rapidly on a lathe-like forming machine. This is where brute force meets skill, forming the curved body of a 120-liter steamer by hand. The disc rotates at high speed. A long steel rod is pressed into its surface, slowly shaping the metal outward. The operator leans in with both arms, using the tool like a lever. It's not automation, it's touch, pressure, and timing. There's a constant low hum as metal grinds against metal, the sound of shaping in real time. Each pass deepens the curve, coaxing the metal into a smooth cylindrical shape. The base begins to take form first, then the sides. Shavings fly as friction builds. It's a controlled struggle between resistance and persistence. You can almost smell the heat rising off the steel. The form is held steady with a center mandrel while the outer edge is pushed progressively outward. You can see the body grow taller with each turn. The operator constantly adjusts angles and pressure to avoid warping. Sometimes you catch a slight vibration, metal flexing just before it gives in. Then comes the real finesse. Tool changes for more precise shaping. One tip flattens the upper rim, another reinforces the base. All the while, the drum spins non-stop. Each movement is deliberate, as if the worker's hands have done this 1,000 times. What's amazing is that this massive pot is being formed from a single disc. No welding, no seams. It's one unified piece of steel shaped by skill and repetition. That unity matters. No seam means fewer weak points under pressure. Once the main shape is locked, a second roller forms a reinforced lip along the top. This isn't just for structure, it's the sealing surface for the lid. Every edge must be smooth, every line symmetrical. Even a 1 mm imperfection could affect the entire lid fit. You can almost feel the torque as the worker braces himself during final shaping. Any wrong move could leave a ripple that ruins the fit. When it's done, the piece is lifted off the lathe. The shine is raw, no polishing yet, but the form is complete. Two identical pots often come out together, formed at once, then gently separated. A clever trick that doubles output without sacrificing accuracy. What looks like a pot is really the result of coordinated force and craftsmanship. It's metal spinning into structure, guided entirely by hand and eye. This is where precision meets motion, where a nearly finished vehicle receives its final form. Inside Toyota's Tsutsumi plant, the last phase of assembly isn't just about putting things together. It's about confirming, fine-tuning, and making sure every detail clicks into place. The vehicle arrives with most internal systems installed, but critical components are still waiting. Workers begin by lifting the car for underbody access. At this stage, electrical wiring is double-checked. Technicians verify harness connections and look for any irregularities in cable routing. It's impressive how human focus pairs with digital diagnostics to catch the tiniest flaws. Mistakes at this point aren't tolerated. It's all about accountability. Next, the front spoiler receives shielding, essential for protecting the structure from debris and airflow impact. Every shield is aligned and secured with calculated force. It's a blend of strength and subtlety. Too much pressure can distort the panel, too little and it won't hold. Wheels and tires follow. A multiple spindle drill system drives each lug nut simultaneously, saving time and ensuring torque consistency. Yellow protective pads are placed between tool and rim, a small but thoughtful detail that prevents scratches during installation. It's amazing how something as small as a foam pad reflects the plant's larger obsession with quality. Then come the doors. Removed earlier to allow better access during interior assembly, they're now reattached. Precise jigs hold them in place as bolts are tightened, ensuring a flush fit. Watching them realign perfectly is strangely satisfying. Once the exterior is complete, the vehicle is lowered again for another round of inspection. Lights, sensors, safety features, each is tested under a controlled sequence. This is more than just the end of the line. It's a final affirmation of everything before it. Every bolt, panel, and plug has a role, and none is left to chance. As the car rolls off the line, it isn't just built. It's verified, refined, and ready to move. There's a quiet confidence in that first smooth glide toward the testing area. This is Okuma's MCRA5 CII in motion, a double-column machining center built for serious cutting power. Its rigid structure handles large workpieces with ease, carving out complex components in aerospace and automotive manufacturing. Watching it sweep across metal with controlled aggression is deeply impressive. That spindle doesn't hesitate, it commands the cut. This facility doesn't just make parts, it orchestrates precision. At Guangda's Rugao base, planetary gears, sun gears, and flanges are produced across dedicated smart lines. Each production unit is supported by virtual modeling and real-time diagnostics. Cutting fluid is reused in a closed system, achieving over 95% efficiency. It's hard not to admire how data, machines, and materials converge with such clarity. Four types of concrete pressure pipes, C300, C301, C302, and C303, each follow a specific manufacturing sequence that blends steel, concrete, and mortar in distinct ways. Each type addresses different structural needs, making them suitable for various pressure and environmental demands. C300 begins with steel sheets welded into a cylinder. Joint rings are added and hydro-tested. Reinforcement cages are built using spiraled rods welded by machines, then placed outside the cylinder. Concrete is poured between the inner and outer molds and cured with steam. The result? A solid, reliable structure built to last. C301 starts similarly, but adds pre-stressing wire wrapped under tension after the concrete cures. A cement slurry coats the wire, followed by mortar spray for surface protection. That tensioned wrap, it means serious strength under pressure. C302 skips the steel cylinder altogether. Instead, two concentric steel cages are placed around an inner mold. Concrete fills the space between the cages and is cured in place. It's a minimalist approach that still delivers impressive integrity. C303 revisits the cylinder design, but swaps the wire for bar wrapping. After a mortar lining is applied using centrifugal force, the cylinder is wrapped with steel bar while rotating. Another mortar layer is added. End caps seal in moisture, and wooden braces reinforce large-diameter pipes. These processes aren't just technical, they're carefully engineered systems that reflect decades of experience and adaptation. Every weld, wrap, and pour has purpose. Watching concrete and steel unify like this, it's unexpectedly compelling. Molten copper flows like lifeblood across Sarco's continuous casting lines. Here, high-purity cathode copper is refined into oxygen-free rods, bare wires, nickel-plated strands, and even silver or tin alloyed types, each tailored for specific industries. The facility spans 77,000 square meters of closed space, equipped with advanced systems for in-house energy generation and quality testing. Physical and chemical labs go beyond internal standards, conducting national-level verification. Watching spools of microwire align with such precision is oddly calming. Even the insulated copper pipes and flattened conductors follow strict dimensional control. Their alloyed variants support applications in motors, electronics, and renewable power systems.